You think I have a hard time drawing shapes on the board now? Wait. Okay. One thing that I forgot to bring up, by the way, last class is, or the last hour of class, I should say, is where the videos will appear. In Blackboard. I'm going to go to a different class because we don't have any videos for this one yet, at least not posted. In that course information button, you can see where you got the instructor information, syllabus, and the instructor schedule. You see down below that, there are links, and that's what they will appear in your course as well. Depending on what web browser you use, sometimes you can click on them and the links will work. Most of the time, it's safest to just copy and then paste them into your browser. And it'll take you to YouTube. Okay, I'm going to shut off the sound. Just the echo over the network. Okay, I didn't get the sound. But you can see all it is what appears on the screen with my voice over it. Okay. So you can see they're incredibly entertaining. I should be nice to myself. If you have to miss class, that's your punishment for missing class, by the way, is you have to watch the videos to pick up what we missed. Anyway, that's where they're at. That's how you find them. And like I said, there are other videos out there. If there's other topics that are related to what we're doing that I have posted out there, feel free to watch whatever you want or share with friends if they need them. That's what they're there for. Okay, let's get back into the math side of things then. So we looked at the basics of whole numbers there and how those numbers work. We want to now look at our other forms of numbers. So we're going to talk about fractions. Every time I mention fractions for the first time, I hear the moans and groans around the classroom. They're not as bad as they sound. The biggest reason people struggle with fractions is most classes tend to teach fractions as this totally separate thing that's got different rules and everything else. That's not true. Fractions work just like any other number. For example, 3/4, the top number is called what? Numerator. There we go. And the bottom number is called denominator. I don't know if you caught me pausing there. A little bit of a side note, I am a horrible speller. I also acknowledge that my handwriting sometimes leaves something to be desired. If anything ever appears up on the board that you can't read, I assure you I intended to write it in English. I either just horribly misspelled it or my handwriting was off. If there's anything you can't read, please don't hesitate to interrupt me and ask me what it says. I promise I won't be offended. So anyway, a numerator, to numerate means to count. So that's actually a count. Denominator, to denominate means to classify, put into categories, or to give a name. So that's just what we had for our parts of a number for our whole numbers. Just like dealing with 3 inches or 3 pounds or whatever, this is 3/4. We have 3 of something. Instead of being inches or anything else, it's fourths. So to understand fractions, we have to understand what does it mean to be a fourth. Okay, I can do better than that. Pretend that looks like a circle. The simplest way is the old elementary school illustration of a pie or a pizza, where a fourth means it is cut into 4 equal pieces. Pretend those look equal where we're at. So one whole object is cut into 4 equal pieces. Or another way of looking at it is it takes 4 of these pieces to make one whole object. The 3 then, that numerator or our count, is saying that we have 3 of those pieces. I can't color within the lines either. So at least I'm consistent. Now we saw up above with whole numbers here that when we add or subtract, we had to have the same name, the same label. Inches and inches make more inches. If we didn't have the same label, like feet and pounds, we could not combine them. For fractions, ever since like 3rd grade, we've been told to add or subtract fractions, you must have a common denominator. That's the same rule. You have to have the same label, the same name. That denominator is the name. And when we added whole numbers, we combined the counts. 2 plus 3 is 5, and we kept the same name. So it stays 7. It's the exact same rules we use for whole numbers. Now, just like with whole numbers, if they have different names, like 1/4 plus 3/5, we can't combine them the way they're written. We have to give them the same name. We have to find that common denominator. So one of the things we need to be able to do with these fractions is to change their name or change the denominator to find the common denominator. One of the things we can do to change the name, just from this illustration, we can take the slices and cut them into more equal slices. So let's take each slice and cut it into 3 equal slices. Pretend these are equal as well. So that illustration is now changed. How many pieces does it take to make a whole object now? 12. I had 4 and I cut each into 3 equal pieces. 4 times 3 is 12. How many pieces do I have there in yellow? 9. We had 3, we cut each into 3 pieces, so 3 times 3 makes 9. Do we have any more or less than we did before? No, it's the exact same amount. 9/12 is the exact same amount as 3/4. It just looks different. We've just given it a new name. We haven't changed its value. And the reason we were able to do that is what we did right here, 3/3. 3/3 is saying it takes 3 pieces to make a whole object, and we have 3 of them. In other words, we have 1 whole object. So we multiplied by 1. That's what we call a unity fraction. A unity fraction has a value of 1. And it's a very important tool throughout all of math. I'm getting into measurement conversions and all that stuff. We use unity fractions for a lot of things. Because when you multiply a number by 1, what does it do to the value of that number? Nothing. It stays the same. So a unity fraction can be used to multiply a number without changing its value. But it can change the appearance. It can change its name. So if we have, most of the time, we can't just pick a random number like 3. We have a certain thing that we need to change it to. Let's say we have 2/5 and we need to turn it into 30ths. If we want to change the name or change the denominator to 30, we have to figure out what do we multiply 5 by to turn it into a 30? 6. So we have to multiply the numerator by the same thing. 2 times 6 is 12. So once again, 12/30 is exactly the same value as 2/5. It just looks different. So now back to our 1/4 plus 3/5. First thing we need to do before we can change those to common denominators is figure out what that common denominator would be. Okay, some of you have it already, it's 20. If we didn't see that as 20, there's a few different strategies we can use. I'll go over a couple of them. One, I could just multiply. 4 times 5 is 20. That will be a common denominator. Now, many of us have been told that you have to find something called the least common denominator. If you just multiply the two denominators together, that often will not give us the least one, the smallest one. But it will always give us a common denominator, and it will always work. We just may have to reduce it at the end or simplify it at the end. Another method that can be used for finding a common denominator is to make a list. I've got my two denominators of 4 and 5. If I count up by fives, that'd be 5, 10, 15, 20, 25, and so on, right? If I count up by fours, that'd be 4. What would be next? 8, 12, 16, and 20. So the first one that is in both lists is the 20. So in this case, the 20 is the least common denominator. Now, there are a lot of fancier methods for finding it involving factoring and stuff like that. If this were a formal, my tongue isn't working today, a formal algebra course, we would go through that because that's the method you have to use if you have algebraic numbers and stuff like that. We're not going to get into that heavy use of variables and algebraic numbers in here. So we need to have a common denominator of 20. So I have 1/4 plus 3/5. I tend to add vertically. It just makes more sense to me. So I'm going to set them up like that. 1/4 plus 3/5. And I need to change the denominators both to 20. What did I multiply a 4 by to turn it into a 20? 5. So what do I have to do to the 1? Times 5, which would be 5. What's this numerator here going to end up being? 12. Perfect. 5 times 4 to make 20, so we have to do 3 times 4 gives us 12. Now that we have a common denominator, we can go ahead and add. Now remember, when we add, we combine the counts, or we combine the numerators. 5 and 12 make 17, and we keep the same name of 20. We keep the common denominator. Let's look at one where, well, let's just do 1/6 plus 3/8. Let's say we're looking at that and we just cannot figure out what the least common denominator is. So we decide we're going to go ahead and just do 6 times 8. What is 6 times 8? 48. So we're going to use 48 as a common denominator. That is not the least common denominator, but it is a common denominator. What's going to go here above the 48? 8. Good. 6 times 8 to make 48, so 1 times 8 is 8. What's going to go here? 18. There we go. 8 times 6 to make 48, so 3 times 6 is 18. When we add now, we have 8 plus 18 is 26, and we keep the same denominator of 48. When we get here, though, what we see is we have a fraction that has a numerator and denominator that are both even, both divisible by 2. Just like we could multiply the top and bottom by the same number, we can reverse that process to simplify a fraction. We can divide numerator and denominator by the same number. 26 and 48 can both be divided by 2. 26 divided by 2 is 13. 48 divided by 2 is 24. So 13 24s. 24 actually would have been our least common denominator. The other thing that can happen with our fractions, we can run into something like this, 30 over 7. This is something called an improper fraction. Now, the word improper implies that there's something wrong with it. And that's not really true. There are times that we actually prefer our fraction to be in that form. In fact, in the next 20 minutes, we're going to run into some examples where we prefer it to be in that form. But we don't like having that numerator bigger than the denominator because the 7 is telling us it takes 7 pieces to make a whole object. If we have 30 pieces, we have more than enough pieces to make a whole object. In fact, we can make several of them. So it's easier for our mind to visualize if we put together those whole objects and then just have some spare pieces left over. Well, to do that, we're going to divide. Now, if you were to punch this in your calculator, 30 divided by 7 is going to give you something like 4.28571429 approximately. That doesn't help us. It does tell us that we can get 4 whole objects out of here. So there's going to be 4, but we need to know how many pieces are left over. 2, okay? The easiest way to go about that for me is to treat this as a long division with remainder. It's 30 divided by 7. This up here did tell us that 7 goes into 34 times. What is 4 times 7? 28. We subtract, there's 2 left over. That remainder is the number of pieces left over in our fraction. There's still 2 sevens. This, by the way, is what is referred to as a mixed number. It is called a mixed number because it mixes whole numbers and fractions together. So for the remainder of our examples of adding fractions, we're going to go to using mixed numbers instead of just simple fractions. So let's say I ask you to add 3 1/8 and 5 3/5. Our first step, now notice the way I wrote those, by the way. I lined up my columns like I would with whole numbers, and I just put my fraction on the end of it. Just like the fraction is the last digit of the number. Because in fact, that's all the fraction really is the last digit of the number there. We do still have to find the common denominator. For 8 and 5, what's my common denominator going to be? 40. Good. This is going to be what up here? 5 40ths. And down here, 24, right? So now, just like adding whole numbers, we'd start on the right and work our way back to the left. We always start with the last digit and work our way backwards. We do the same thing here. The last digit is the fraction, so we do that first. 5 40ths and 24 40ths makes 29 40ths. Then the next digit, 3 plus 5 is 8. Now, it doesn't always stay that simple. We might have 5 3/4 plus 2 5/6. What will our common denominator be? 12. Very good. What's our numerator on this top one? 9. Good. 4 times 3, so 3 times 3. What's the numerator on the bottom one? 10. 6 times 2 to make 12, so 5 times 2 is 10. Now again, we're going to start at the end of the number and work our way backwards to add. 9 12ths and 10 12ths is 19 12ths. Anybody see the issue there? It's improper, isn't it? If I break that into a mixed number, what do I get? 1 7 12ths. Just like with whole numbers, I keep part of it and I carry part of it. This is the fraction digit, so I'm going to keep the fraction, the 7 12ths. I'm going to carry the 1. 1 and 5 is 6 plus 2 is 8. It is 8 7 12ths. When we go to subtract, remember we said addition and subtraction are inverses, they're the same operation. They follow the same rules. So just like addition, we must have a common denominator. You'll notice, by the way, I always rewrite the whole number, just because if I don't, I tend to sometimes forget about it. So the 8 and the 2 I rewrite. What's my common denominator here? 30. Very good. What's this top fraction going to be? 18/30. The bottom one, 5/30. And now, just like with whole numbers, again, we start at the right and work our way back to the left, and we subtract. 18/30 minus 5/30, 13/30. We combine the counts. 18 minus 5 is 13, and we keep the same name again. We keep the common denominator. Now 8 minus 2 is 6. You might notice a pattern developing here. It doesn't always stay that easy. We might have 9 1/4 minus 5 what do I want to do? We'll go 4/5. As always, well, not as always, is with any addition or subtraction, we need a common denominator. What's our common denominator going to be? 20. What's the top fraction going to be? 5/20. Bottom? 16/20. We're going to go left to right or right to left to subtract again, starting at the end and working backwards. However, here, 5/20 minus 16/20 gives us a problem. We can't subtract a larger number. With whole numbers, what would we do? We'd borrow. We're going to do the same with fractions. We borrow from that next digit, the 9, and it becomes an 8. The difference is what happens here. Perfect. What we borrowed was one whole object, and the denominator tells us that whole object is 20 pieces. 5 plus 20 is 25/20. We have to add the denominator to our numerator when we borrow the 1. And now we subtract 25 minus 16, 9/20. 8 minus 5, 3. So 3 and 9/20. Let's do one more of those. Let's do 362 1/4 minus 179 2/3. Just a little bit more difficult. It really is more difficult. It just looks intimidating. The common denominator is 12. Good. What's this top one going to be? 3/12. The bottom one? 8/12. We go to subtract. There we go. New computer, and it hasn't got quite fine-tuned yet. And we go to subtract. 3/12 minus 8/12. Can't do it. So what do we have to do? Borrow from the 2. It becomes a 1. And what do we do here? Add 12 to it. It's now 15/12. So now we subtract 15 minus 8, 7/12. Then we just keep moving over to the left. 1 minus 9 can't be done, so we're going to borrow. This will be a 5 and an 11. 11 minus 9, 2. 5 minus 7, we got to borrow. So that's 2 and 15. 15 minus 7, 8. 2 minus 1, 1. 182 and 7/12. Now, before I move on, I'm going to pause here for a second. Does anybody have questions as to where the 3/12 and the 8/12 are coming from the original fractions? Okay. So next, we get to move on to multiplication and division. Now remember, when we multiplied up above, we saw that when we multiplied or divided, we did not have to have the same name. For fractions, that means we do not have to have a common denominator. 1/4 times 3/5? Sure, we can do it. Remember, with our whole numbers, we combine the counts, we combine the numbers, and we also combine the names. Inches times inches to make square inches. Feet times pounds to make foot pounds. We're going to do the same thing here. We're going to combine the counts. What's 1 times 3? 3. Then we'll also combine the names or the denominators. 4 times 5 is 20. 3/20. We might have 3/8 times 2/5. What am I going to get there? 3 times 2 is 6. 8 times 5, 40. Now at that point, I notice, what can I do with this? Both of them can be divided by 2 to reduce it. 6 divided by 2? 3. 40 divided by 2 is 20. Now some of you might be looking at this and asking, well, why didn't he just cross cancel in the beginning? Others right now might be wondering, what's cross cancel? Now what it is when we do this multiplication, we're going to have 3 times 2 on top. We're going to have 8 times 5 on bottom. We notice that the 2 and the 8 are both divisible by 2. So we can actually divide that out before we multiply. So 2 divided by 2 is 1. 8 divided by 2 is 4. And now when we multiply, 3 times 1 is 3. 4 times 5 is 20. So we get that answer reduced before we do the multiplication. And a problem like this, it's about the same amount of work either way. But I can give you an example like 24/25 times 35/36. I could multiply that out. 24 times 35 is 840. And 25 times 36 is 900. And then I'd have some reducing to do. Or I could take my 24 over 25 times 35 over 36. And I can do that cross canceling. Now, some textbooks called this cross multiplication, by the way. But there are other processes that are called cross multiplication in other textbooks. So I'm calling it cross canceling so that we're not calling 2 different things by the same name. But if we look at this, what can we cross cancel here? 35 and 25 can both be divided by 5. What is 25 divided by 5? 5. What is 35 divided by 5? 7. So we've reduced that. Now we can cross cancel the other way. What can both of those be divided by? 4 would do it. 6 would do it. 2. 8 won't go into 36. But there is one bigger one yet. Not quite. 12 would work. Now let's say the first one we saw, somebody said 4 was the first one we heard. What is 24 divided by 4? 6. What's 36 divided by 4? 9. Well, there we still see that both of them can be divided by 3. What is 6 divided by 3? 2. 9 divided by 3? 3. So we've always been trained that we have to find that largest number that divides into both. We don't have to. We can go step by step like that. So now we've got 2 times 7 is 14. 5 times 3 is 15. A little bit simpler than 840 over 900. Now, trying to reduce that 840 over 900, if you went by the traditional system of finding that greatest common factor, that largest number that divides into both of them, you would drive yourself nuts trying to figure out that that's 60. But you can just look at it and say, hey, both of them end in zeros, which means they both divide by 10. What's 840 divided by 10? 84. What's 900 divided by 10? 90. Now you might be looking at that still and think, well, they're both even, so that means I can divide them both by 2. 84 divided by 2? 42. 90 divided by 2? 45. Now it gets a little trickier here. But they both divide by 3. A little trick, by the way. 42, what's 4 plus 2? 6. Is 6 divisible by 3? Yeah, so 42 is divisible by 3. 45, what's 4 plus 5? 9. Is 9 divisible by 3? Yeah, 45 is divisible by 3. 42 divided by 3 is 14. And 45 divided by 3 is 15. So we would get the same answer. To me, it is easier to divide and reduce here than it is there. If you don't mind working with the big numbers, that's fine. By the way, many of your scientific calculators have a fraction function. You can enter these in and it'll do them. I'm not going to spend any more time multiplying simple fractions. We're now going to go to mixed numbers. Let's do 3 1/4 times 7 3/5. Okay, that is what we usually do. You can't actually multiply mixed numbers, but the process for multiplying mixed numbers is extremely difficult. I issued this challenge for several years, and then somebody actually did it, so I had to stop. I issued the challenge that if you could actually show me how to multiply those as mixed numbers, I would give you an A on the first unit of the course, and somebody actually did it. So I can't do that anymore. But I've had one student in 17 years that actually knew how to multiply the mixed numbers. So we cheat. As Della said, we turn them into improper. 3 1/4, 13/4. Good. The way we did that was we had to break these 3 whole objects back into pieces. The denominator tells us that each of them is 4 pieces. So 3 times 4 is 12. We add those to the one piece that was already there, it gives us 13/4. Over here, we do the same thing. We multiply the 7, the whole number, by the denominator to get 35, and we add that to the 3 to give us 38/5. What did I do? 28 instead of 38. Thank you. At this point in the night, the little hamster has been off the wheel for a while. To be honest, the little hamster is down in the room trying to get in the room with the rest of them. So if we look at this, just like any other fraction multiplication, we can cross cancel here. Both the 4 and the 38 can be divided by 2. 38 divided by 2? 19. 4 divided by 2? 2. So that makes it a little bit easier. 13 times 19 is 247, right? 2 times 5 is 10. Perfect. Some of you can do that in your head because it is dividing by 10. But let's go ahead and do it out the long way. You're just going to do a long division with a remainder. 10 can't go into 2, but it can go into 24 twice. 2 times 10 is 20. Leaves us with 4. Bring down the 7. 10 goes into 47 4 times. 4 times 10 is 40, and there's 7 left over. So that's 24 7/10. Now, just for fun, does anybody want to see how you would multiply those as mixed numbers? Sure? Okay. There you go up. Sure, make sure I have the right fractions. Where are they? Okay. Well, we'll come back and do another example. 3 1/4 and 7 3/5. You're probably lucky I didn't do my whole numbers. I mean, whole numbers is assumed you know coming in here. But in some classes, some of the more basic classes, I'll actually go through and show you 3 or 4 different ways to add whole numbers. Instead of carrying, there's other processes you can do. We won't do that to you. That look on your face is saying, please don't. When we multiply whole numbers, we have like 32 times 25. We have to take the 5 times the 2, but we also have to do the 5 times the 3, right? Same thing happens with our mixed numbers. The 3/5 has to multiply the 1/4. We also have to do the 3/5 times the 3. So we're going to do the 3/5 times 1/4. What does that give us? 3 times 1 is 3, 5 times 4 is 20. Then we have to do the 3/5 times 3. How do we multiply a fraction by a whole number? Make it 3 over 1. Now we don't need a common denominator. We just need to make the 3 into a fraction by putting it over 1. You're correct. Now 3 times 3 is 9. 5 times 1, 5 9/5 or 1 and 4/5. Now we move over to the 7. 7 times 1/4. We have to do the same thing. 7 over 1 times 1 over 4. 7 times 1 is 7. 1 times 4 is 4. 7/4 or 1 3/4. And then finally, we have the 7 times 3. 21. Now we have to combine those. We need common denominators. Common denominator is going to be 20. That stays 3/20. This is going to be 1 and 4/5 is 16/20. This will be 1 and 3/4 is 15/20. Of course, the 21 doesn't change. We add 3 and 16 is 19, plus 5 is 34/20. That's improper. That would be 1 and 14/20. The 14/20 can be reduced to, bless you, 7/10. So we keep the 7/10 and we're going to carry the 1. 1 plus 1 is 2, plus 1 is 3, plus another 1 is 4, and we got the 2. We got the same answer. Personally, I'm going to stick to improper fractions. I do that like 2 or 3 times a year just to scare beginning math students. Let's do an example now of going back to improper fractions so we can get that rutted back in your head. Time to go down to the law enforcement class. So let's do something like 3 1/5 times 2 3/4. Tell me what to do. But remember, all we have to do is make them improper, right? Perfect. 3 times 5 is 15, plus 1 is 16/5. Perfect. 2 times 4 is 8, plus 1 is 11/4. Now what? The 16 and 4. Yep. Bless you. 16 divided by 4 is 4. And 4 divided by 4 is 1. Good. Now we can multiply. What is 4 times 11? 44. What is 5 times 1? 5. There you go. 44 divided by 5 is 8. 8 times 5 is 40, so there's 4 left over. Not so bad. Time to look at division. I've told you that multiplication and division follow the same rules. When we multiplied, we just multiplied straight across, didn't we? Can I divide straight across? Can I do 12 divided by 4 is 3? 20 divided by 5 is 4. That's 3/4. Is that correct? Yeah, that's the right answer. Does that work every time? Sure it does. So why don't we do it that way? Well, because we run into problems like 3/4 divided by 2/3. If I tried to divide straight across there, 3 divided by 2 is like 1.5, and 4 divided by 3 is 1.3333333333333. It goes on forever. Not going to work out right. How have we been taught to divide fractions? Change it to multiplication. The first fraction doesn't change. The operation is always working on the second number. So instead of dividing by 2/3, we change it to multiplying by 3/2. We use that word reciprocal. We multiply by a reciprocal. So now 3 times 3 is 9. 4 times 2 is 8. So that's 1 1/8. You just flip it, yes. The reciprocal is just flipping that second fraction. Now, believe it or not, this process here of taking the reciprocal and multiplying came from what I showed you up here. Now, if you get easily confused, I'm going to have you shut off for a second, not watch what I'm about to do. But the way this used to be done, the long version of multiplication, the real version of division, the real version of division looks like this. I have 3/4 divided by 2/3. The 2/3 is reduced. So I'm going to take the numerator, the number I'm dividing by, the 2/3, the numerator times the denominator. 2 times 3 is 6. I am going to use the 6, come on, to rename my first fraction, 3/4. What is 3 times 6? 18. What is 4 times 6? 24. 18/24 is equivalent to 3/4. Same fraction. I've just changed this name. I've renamed it. Now if I divide by 2/3, what's 18 divided by 2? 9. 24 divided by 3? 8. 9/8 or 1 1/8. That's exactly what I got over here. How on earth do they get from this mess to multiplying by a reciprocal? Again, it's not as big of a leap as you would think. At some point, somebody looked at this and realized if we stretch our order of operations a little bit, and I do this division first, what's 6 divided by 2? 3. What's 6 divided by 3? 2. What we get when we do that division is just this second fraction flipped over, upside down. So they gave it the name of reciprocal. Then what's left is multiplication. It's always the second fraction. The operation always operates on the number that comes after it. So if I have 5/8 divided by 5/6, what am I going to do? 5/8 doesn't change. That becomes 6/5, and now we are multiplying. Now that it's multiplication, we have all the same rules we did for multiplication. Anything we can do with multiplication, we can still do here, which means we can cross cancel. 5 divided by 5 is 1 in both cases. The 6 and the 8 both divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So 1 times 3 is 3. 4 times 1 is 4. So 5/8 divided by 5/6 is just 3/4. So on to the next step. 7 1/3 divided by 3 1/2. Now, if we're going to take our fractions when we divide and do the reciprocal and turn it into multiplication, it makes sense that for mixed numbers, we'll do the same thing we did for multiplication, which was turn them into improper fractions. So 7 1/3 is going to become what? 22 1/3, 22 thirds. 7 times 3 is 21, plus 1 is 22 thirds. 3 1/2 is going to become 7 halves. Good. 3 times 2 is 6, plus 1 is 7. Can I cross cancel the 22 and the 2? Say no. No, I can't, because at this point it's still division. I have not taken reciprocal yet. Does this become 3 over 22? No. The first number does not change. It's 22 over 3. Unless I screw up and write it as something different. 22 over 3. It becomes multiplication. Remember, the operation works on the number that comes after it. The 7 halves becomes 2 7s. Now we could cross cancel if there was anything that did cancel. Here there is not. So we're just going to multiply. 22 times 2 is 44. 3 times 7 is 21. Now we do have to break that back down into a mixed number. 21 goes into 44 how many times? Twice. Good. 2 times 21? 42. There's 2 left over. So there's 2 and 2 21st. Not so bad. Better than start sticking the eye. Okay, it is time for our second break. Let's do another 10-minute break. It's 7:20 right now. We will come back at 7:30 for our last hour. Look, that says another hour. Oh my.